Today we will be solving systems of equations with three variables. A solution to an equation in three variables is an ordered triple, x, y, z. To solve, we're going to use a triple elimination method. I've color-coded each step to help you follow along. Feel free to color-code your notes as well. So I'm going to go along with each step using the example below. Step 1 says to express each equation in the form ax plus by plus cz equals d. That's standard form. As I look through these three equations, I can see that they are all in the correct form. X, then y, then z, equals, and then my constant. One thing I'm going to go ahead and do is number these equations so that as I use them throughout these steps, I can reference them to equation 1, 2, and 3. Okay, step 2 says that we're going to multiply any two of the equations by some non-zero number so that you eliminate one of the columns. So essentially we're eliminating one of the variables. And it doesn't matter if we eliminate x, y, or z. At the beginning for step 2 we get to choose. If I look at the coefficients of my x, I've got a 2, a 1, and a negative 1. So that one seems fairly easy to eliminate. The y's, I have a 1, a negative 2, and a 3. So the 2 and 3 will be harder to match. And then the z's, I've got a negative 3, a 1, and a 4. So the 3 and 4 will be a little harder to match as well. So I'm going to eliminate the x's. So step 2, we're going to choose any two equations. So let's just do 1 and 2. So equation 1 is 2x plus y minus 3z equals negative 11. And then equation 2 is x minus 2y plus z equals negative 3. If we want to eliminate the x's, I need to multiply this second equation by negative 2. This leaves me with negative 2x plus 4y minus 2z equals a positive 6. Then I'm going to go ahead and rewrite this equation below it so it's easier to add. 2x plus y minus 3z equals negative 11. Okay, so now we're on step 3. Add the two equations from step 2, and you should have one equation with two variables. So we're going to add these two. Negative 2x plus 2x is 0, which is what we wanted to eliminate the x's. 4y plus y, 5. Negative 2z minus 3z is negative 5z equals 6 plus negative 11, negative 5. Now we're on to step 4. Choose another pair of equations and again multiply by some non-zero to eliminate the same variable. So that part's important. Since we eliminated x's, I have to pick two more and eliminate x's again. Well, I've already used equation 1 and 2, so I have to use equation 3. Negative x plus 3y minus 4z equals negative 6. But for my second equation, I can use 1 or 2. It doesn't matter. I'm going to go ahead and use equation 2. X minus 2y plus z equals negative 3. Now, I'm going to add so that we can eliminate the same variable. We should have a second equation with two variables. So we're going to add negative x plus x is 0. 3y plus negative 2y is 1y. Negative 4z plus z, negative 3z, and negative 6 plus negative 3 is a negative 9. So now we have two equations with two variables. So now we're on to step 6. We're going to use our modified system from step 3 and step 5 to solve, and we can use elimination, graphing, or substitution. So I'm going to put these two equations together. 5y minus 5z equals a negative 5, and y minus 3z equals a negative 9. You could use substitution here, solve for y, and then plug it in. or you can use elimination. I'm going to go ahead and solve for y in this second equation by adding 3z to both sides. So we get y equals 3z minus 9. I can then take this y equals 3z minus 9 and plug it in to the y of this equation. So we're just taking these two green equations and acting as if we're just solving a system of two equations like we did in the past. So we have 5 in place of y, 3z minus 9 minus 5z equals a negative 5. So we'll go ahead and distribute and get 15z minus 45 minus 5z equals negative 5. Combine your like terms. We get 10z, and we're going to add our 45 to both sides. We have 10z equals negative 5 and 45 gives me 40. So z equals 4. Now that I've solved for z, I'm going to take that z equals 4 and plug it into one of the systems of 2. So I can plug it into either y minus 3z equals negative 9 or 5y minus 5z equals negative 5. I'm going to plug it into y minus 3z equals negative 9. So y minus 3 times our z is now a 4 equals negative 9. Y minus 12 equals negative 9. Add the 12, so y equals 3. So I now have z is 4, y is 3. So we've solved this system of 2 how we normally would. Then we're going to take both of those and we can plug it back into one of the 3 original equations. So y equals 3 and z equals 4, I can plug into one of the originals. I'm going to choose equation 2. It absolutely does not matter which equation you plug it into. So we've got x minus 2y plus z equals negative 3. I'm going to plug in x minus 2 in place of y we have a 3, plus in place of z we have a 4 equals negative 3. So x minus 6 plus 4 equals negative 3. X minus 2 equals negative 3. X equals negative 1. So now I have my x, my y, and my z. Your final answer needs to be x, comma, y, comma, z. So we have negative 1, 3, 4. Your final answer is negative 1, 3, 4. You're going to flip the page over and you're going to attempt this problem on your own. You'll have to submit your answer into the computer, and then we will go over this next question together.